from this special data set. For example, recommendation algorithm, and also to help to improve, for example, cooking recipes, different kind of ingredients if we have any allergy, for example, or health constraint like nutrition issue, sugar issue, whatever. And as I mentioned, allergy like gluten or milk allergy. And one special use case I will go through is about the carbon footprint reduction, which is important in nowadays world climate change. If I go through many kind of data, here is an example of a French data set. We can see that there are many different kind of food, different kind of ingredients, and of course it's important to focus on big data properties. As it was mentioned by Dr. Demenchko in 2014, of course we will look at 5 properties: volume, variety, velocity, validity, veracity, and volatility. And not only the type of data, but how the data are structured together and how we understand the data. That's part of collective intelligence and semantic use we will see later. And then this kind of big data inspires the new data model. How to link data, we will look at some example, and also how to validate the data in terms of semantics and integrity and so on. So it's very important also authenticity of the data. And then we will see how it will increase in terms of life cycle and evolution. And of course, something which is the informatics of Internet of Things, smart kitchen, how to introduce new analytics way to get data from different way, like real-time analytics and machine learning analytics. But then we will see what is important for carbon footprint. Here is just to remind you the 5 V of big data in terms of volume, in terms of veracity, variety, velocity, and value. So we'll see how these 5 properties are very important for the cooking recipes and data set. So if we look at the current world data set in the food-related research, first, the first point we have to look at is the categories, I mean how diversity of the data set. So we have, we can see all the orange variation from 15 classes to our data set is now over 35,000 classes in terms of categories and variety of type of cooking recipes. And then the extension were between data, example of data, as for example images, and recipe itself. We came from a recipe data set like Muli, recipe 1 make, and data recipes. So that's also on the evolution of how it has been important to increase the number of data sets, the size of the data set, to understand more and to increase the way to, if we see the focus process, like not only to recognize, but also to recommend and to understand different kind of food in terms of multi-recipe, single recipe, and so on. So in order to understand more the ingredients themselves, but also the volume of and the nutrition target of each dish. That's also important. And also, we see that there were very additional annotation as metadata, like label and the region of condition and so on, to understand more closer detail for each type of data. So here we've been working on also extended variety of cooking recipes, and that was the target to have 35,000 classes of dish. like main categories, appetizer, main dish, dessert. And then a side dish, occasional dish, and New York cooking, for example, for special events. But it was also important to include, for example, we started with more than 1,580 classes of Indian dish in terms of roti, curry, different kind of ingredients like mutton, prawn, fish, and so on, in order also to understand the different variety of rice, for example, preparation, chutney, and salad, and so on. So in order to have also not only a Western approach, but also to include local food like is India and different kind of way and process, for example. So our data set was an evolution of the existing and the previous work, started in with 9 classes, like the egocentric food, 5,038 images, and in 2020, the Asia, the latest before us, Asia Food 500 with 400,000 images and 500 classes. So we trying to target more with different way to understand the type of the food, but also to improve the data set itself. So when we are talking about a variety of data, so our own data set with different kind of data structure, semi-structure, structure, and so on, text, photo, and video. But it was also a way to understand that we should go more beyond the traditional media. So we created in 2012 with Professor Guinea, Professor Gulliver, and myself, the concept of multimedia, multiple sensorial media. And that's why also it was a focus on our own data set in how to insert or how to get data with at least 3 multiple sensorial experiences. I mean, like viewing, hearing, and smelling, for example, touching, for example. So it's a way to have 3 different kind of sensorial experiences in our approach. So, for example, here, if we have also an issue of variety of dish for one dish. I think everyone knows this kind of dish. And the importance is authenticity or personal expectation. So, what kind of dish would you use for this? So, a special way to prepare rice in India. So maybe there are some authentic way to do, authentic dish from India, but still some not original way to do. So that's authenticity where we have to take care of that, but also we have our own expectation in terms of preparation, in terms of taste, spiciness, for example, and the combination of the different way to prepare and the different ingredients. So that's also important. Another example here is what we can call collective intelligence challenge in terms of how to understand the dish from the semantic point of view. We have 2 similar dishes here. But different way to prepare, different way when we receive to look at it. We have a pastry over this dish, and the other one we have more onion and bread, and with the cheese on the top. So the same name, like onion soup, but different way to prepare and different description, and when we receive, we have, of course, different expectations, because in the first case, maybe we don't know this kind of dish, and we are expecting different kind of ingredients inside. But here also, in the first example, we can see we use forks on the left side and the spoon on the right side, which are going to use from the extreme left, extreme right to the center of the table. So that's also important to avoid any interpretation and also to try to match the expectation from the customer and what the restaurant is providing. Another important thing is between the dish and the mood interaction. When we are handling multimedia, of course, from the first point of view, we will have multi-sensing. We can smell the dish, we can, when we cut or open, we can see some crunch, whatever, and we will also taste when eating. That's the tasting experience. But then from our mood, we have different kind of expectation. We saw, for example, in Japan, we have photo in the menu, so we have we could see in the restaurant at the reservation when we order the dish, we have some expectation, and then at the end of the meal, we have our satisfaction or unsatisfaction level. So that's part of our mood, and so it's. This kind of experience is interaction or intersection between the dish itself, in terms of different sensing, the tasting experience, and our expectation, and at the end, the final are we satisfied or are we unsatisfied? That's also a key issue in this kind of data set. So traditionally also, when you are talking about data set, it's injection. We have different steps from cleaning, registration, getting enrichment with metadata, and then to go through data analytics, modeling, prediction, and so on in terms of, we will see some challenge later, and then we have to deliver the data according to some requirement and user-oriented expectation. Something which is also very important in the evolution of big data is the fairness of the model, in how to improve the findability of our data set. When we search, how the richness of the data, the metadata, it could be multilingual point of view, it could be more detailed in the structure of it. You have different kind of naming from the same dish, according to the region, according to the process, or the way to do a special dish. Accessibility is also important in order to let any kind of citizen accessing to the data, that need to understand the recipe, the way to do, how to do. It could be from very expert in cooking, but also from any new learner. So it should be very easy to do, and accessibility is also for any people who need different kind of support to understand, to learn, and so on. Interoperability is also important in order to exchange data set, that means to move from different kind of facet, different kind of metadata, different kind of way to, from computer to smartphone, or like to go to start from multimedia to text only, for example, or visualization only, as another example. So that's very important, interoperability in how to exchange according to the variation of interface, and to keep the standard also. Otherwise, the system and the dataset will not be accessible, and you will not be able to exchange this data in the long term target. Usability is also important in order to understand how to use this dataset from different point of view, different way of accessing, but also maybe you want to use the data as kind of knowledge-based environment in order to start to learn from new target. So reusability, how to integrate this data set or see access to some view or some cluster, for example, that means some classification of the data according to your own algorithm or your own environment. And it could be also for different purpose. It could be for training, learning resources, and interaction. So that's also part of all this knowledge environment, as it was mentioned in 2017 by Dr. Chacon. Then if we go more in detail in the vocabulary, it's also important to understand the different terms according to some taste, for example, here. Is it fresh, lemony, to be able to enable the user or the citizen to express some testing experience with some word, but also it could be metaphor, as we will see later. Also sometimes, for example, here we are comparing the English way to express a good testing with the Japanese way of also expressing good testing. So is it a pretty good testing? Is it quite good testing? Passably good testing, for example, and different way also to express in Japanese. So that's important to be able to understand that for to link experience, real experience dish with this kind of vocabulary. You need to understand that in that case, a special case of a special dish, then the citizen use quite good testing, and in Japanese it could be either nakanaka oishi or nakanaka umai, for example. So it's understand also the cultural way of expressing a testing experience. As I mentioned, we could come with visual metaphor. So for example, we have a first metaphor related to bitter, and the second one to sour expression. So it's a way to, sometimes we don't remember, or we have to link an experience to a special metaphor, a visual metaphor. So here it's a way to have a direct relationship between a term, an expression, and an experience with a visual metaphor. So it's a real topic. That's also sometimes important because sometimes it's difficult to express or to relate a special experience to a special dish or special case. And of course, each cultural way to express, for example, the sourness or the bitterness might be expressed with a special food. So it's also a way to have multifaceted experience. So also, which is important in the data set in order to learn more is, for example, the structure of cooking recipe. So here we are first using a chromosomic way to structure a recipe. So we have a chromosome with many features. So we have at first the metadata, difficulty, preparation time, the cooking duration, portion, and so on. And then we have the list of ingredients with their own metadata, volume, unit, and so on. And then the different preparation steps. And then at the end, more metadata because we have, for example, related multimedia, photo, sound, whatever. So we may have more metadata to describe at the end. So also what we started to do was to classify different kinds of recipe. So it's, we call it CRWB vocabulary and classification. So in terms of difficulty of preparing a dish, different kind of allergy, is it a milk problem, eggs, gluten, lactose, and so on. Different kind of events, which are very important. Sometimes like anniversary, birthday, Christmas, and April, whatever, and so on. So also some target, health target, anemia or anti-diabetic target. And sometimes we have to also to understand the duration of the preparation. Is it a fast or quick recipe to be done, or different kind of duration, or I want also the target, what kind of visitor will enjoy this meal. Also, we need to use some knowledge background. For example, the language thesaurus, which was the last update was in 2017. It's a way to describe not only the food, but the process, the way to prepare, the preservation, and so on, with a different ID classification and different facets. So here, if I go more in detail, we have, for example, the product classification from detailed supplement, food additive, and different food coming from Europe, international, US, and so on. And then here we go more in detail, the second and third layer, like food commodities and plant origin. So we are on the fruits, and then we could use berries and all small fruit, for example, or assorted tropical and subtropical fruit. Then we are able to plug our own classification because we leave of this taxonomy has some limitations. So each leaf has, we need to extend or enhance our metadata set with our own way to describe each fruit, for example, or each vegetable later. And we are also, when there are some additional food, or for example, cheese, so there are some special way to classify. So this kind of classification is a way to understand more the metadata and to give some additional knowledge base in the background for the process. So an example, we have fish, salmon, so we have ingredient, contextual information in terms of where and when it's better to fish, to get this fish, and then the nutritional information in order to understand or evaluate the cooking, according to the cooking process, how will be the nutritional background of the dish. So here, when we are using a chromosomic approach, we are able, for example, to process the recipe from a textual point of view and to get the action. And from that action, we are able to build an execution plan in order to understand the different evaluation for each action, the input ingredient, the output, and so on, to derive all the, for example, the nutritional aspect or the carbon footprint aspect of a special cooking plan. Here we have gone with extracting more action from the recipe description, and then to build some chromosomic vector, and then to be able to have a chromosomic way to optimize, to get similarity between recipes, or to understand the ingredient also more in a deeply way, so in order to optimize that part too. Also, it's important to include our own ontology to upper ontology. So, for example, the SUMO suggested upper merge ontology. And which is very important for us, in the middle we have the process way to. So here it's a way to connect our way to describe cooking process as a part of the sumo ontology. And the same for the dolce ontology. So if we look at in the middle, so we start from particular, perdurant, stative, and process. So we have again the way to connect our own cooking process taxonomy to that dolce ontology. So here is an example. So we connected to Dolce our own small part of our own cooking process, like dry heat cooking, moist heat cooking, and dry and moist heat cooking, for example, and so on. So each would be we have subcategories, and then for each type of cooking we may have a parameter in order to understand what is like a chemical reaction on the ingredient, what is the property, what are the properties of the result mixture, for example. That's also important, and so on. So when we are looking at intelligent food analytics, we have three kinds of challenges. The first challenge is a top-down approach. We start from a smart fridge or traditional fridge, and we want to understand the ingredient of this fridge, and then we generate the dish, time and calories ranking, for example, according to each dish process and cooking. The second challenge is more a bottom-up approach. We start from a dish, and we want to optimize this dish according to some constraint. Lactose-free milk, for example, vegetarian, or we have to reduce some calories. We have to reduce from 800 calories to 400 calories, so that's also part of the constraint. And then means that we have to optimize from the bottom, go back to the ingredient, and also to change the ingredient according to the constraint, but also to keep the same kind of taste, because that's also part of the expectation. Otherwise, maybe the dish name will change, and also we will maybe it will not be satisfied for our guests. And the third challenge is, recently we started on that, is to have a carbon footprint reduction. We work on copper, the carbon footprint recipe optimizer. So here, the target is when we submit a recipe plus a target budget, we are able, the system is able to understand the recipe, but also to be able to reduce the carbon footprint according to the ingredient impact on the recipe. If we buy rice not locally but coming from abroad, maybe the carbon footprint of that rice will increase our overall carbon footprint in the recipes also. So that's mostly the target, getting ingredients which reduce our carbon footprint, and also from the knowledge base, the price of ingredient and the origin, that's also part, and to have a kind of real-time update ingredient process in order to get or to try to get the target expectation from the user, like a chief, like a housewife, or a student trying to reduce the carbon footprint impact and getting a good price, a good budget for this new dish. So let's go through this use case, and we will review a different point of view of that. So first,